Welcome to this OST2 lecture about the TCTI configuration and eSAPI context in the TPM2 TSS. In this lecture, we will learn how to use the Enhanced System API, or for short eSAPI, to generate a primary key. And to be able to use eSAPI, we need to make some initialization steps. First, when using eSAPI, we need to have an ESYS context, an eSAPI context. This is done by defining a pointer variable of type ESYS_context. This variable holds the information about our connection to the TPM and any metadata during our TPM usage, for example, the name of a TPM key. The ESYS context is initialized using the ESYS_initialize API. We feed the ESYS context as the first argument in the ESYS initialize API call, where memory will be allocated for the ESYS context and initialization of the TPM communication will be done. The type of TPM communication can be defined in the second argument called TCTI, and we'll talk about this more in the next slide because there is a difference between what the TCG defines as TCTI and how the TPM2 TSS looked at TCTI and implemented it. For now, we can just use no in place of the second argument, and this will trigger the TCTI loader, which we will also talk about in a moment. The TCTI loader will go through the available TPM TCTI libraries and try to find a TPM to talk to. As you can imagine, this is very useful during development and testing, but for production applications, it's better to have our TCTI defined, which one we want to use. Then the last argument of the ESYS initialize call is the ABI version, the application binary interface of the TPM2 TSS components. And in almost all cases, we can just set null here, so this will use the default latest variant. In our lab environment, we use a TPM simulator. Therefore, we need to manually give the TPM2 startup command, and this is done using the ESYS startup eSAPI. Here is an explanation why TCTI in TPM2 TSS differs from what the TCG defines as TCTI. It is a good reason, and it causes a bit of confusion, and that's even explained in the documentation that I've linked here in the source code of the TPM2 TSS. Under the doc folder, there's a TCTI document that is very verbose, and these pictures are taken from there because I think they visualize the architecture pretty well and how it works. In a nutshell, TCTI by the TCG specification stands for TPM Common Transmission Interface, where in the TPM2 TSS stack, anything that implements a library to talk to the TPM is seen as TCTI. So, as mentioned in the documentation, the terminology is a bit slappy in the stack, but the idea is good, and let me show you why. So here we have SAPI as an example, and this could be eSAPI or FAPI, it doesn't really matter, it follows the same pattern. So once we send our eSAPI API call, that's translated to a TCTI API as defined by the TCG. But then, in order to communicate to the TPM, this needs to be transferred over some kind of a layer, communication layer. That could be a physical layer, it could be a socket, as we'll see with the TPM simulator on the last picture here. But let's go step by step. So we go from eSAPI to TCTI API as defined by the TCG. Then we go through some communication layer that is implemented by a TCTI library for the TPM2 TSS stack, and then we reach the TPM. The response walks the opposite direction. Now, if we want to use a physical device or the resource manager available in Linux, we'll use the TCTI-device library. And we'll specify this in our TCTI initialization when we invoke the ESYS initialize. We'll show that in a moment. So here we also have a configuration parameter that says, okay, this is the device I want to talk to, this specific one. And this can be dev TPM, or if it's the resource manager, in this case, it is dev/TPM RM0. Now, if we take it a step further, because TPM can be interfaced in multiple ways and there are multiple variants of TPMs, for ease of use, especially during development and during prototyping and testing, it's very handy to have a TCTI loader. This is a component that loads different TCTI libraries, like TCTI device, for example, here, or the TCTI MSSIM or the TCTI SWTPM, depending on what simulator we're using, and it walks through the different TCTI libraries until it finds a working TPM. So in this case, the TCTI loader is passed a configuration string, which says we'll be using the TCTI device library and we want to talk to this particular device. So we're making the TCTI loader job easier. And also we can even specify the order, and if we don't, there's a default order that is described in the TCTI document. Now, the last picture describes the most interesting case to us, which is using the TPM simulator. In this case, this shows the steps for talking to the simulator by Stefan Berger. We use the simulator by Kim Goldman, and the difference is mainly in the first 5 letters here. Instead of software TPM, SWTPM, we will type MSSIM, and the configuration string continues the same. We say that we want to talk to the localhost, which is our own machine, or in this case, the Docker, and then we want to talk on the 2321 port, which is the default one. So once we set this, the TCTI loader will load the proper TCTI-MSSIM library or TCTI-SWTPM library. Then it will pass that configuration string to that TCTI library, so it can actually send our command over a socket to the TPM simulator, and then we'll receive the response in the opposite direction. So let's take a closer look at the TCTI initialization. But first, here's something very interesting that I wanted to show why the approach of implementing TCTI libraries, even though causing a bit of confusion about the terminology, isn't a good approach. It's a useful approach because there are even libraries, TCTI libraries, that allows us to talk to a TPM over USB. I've selected just 2 examples. The one is using STDI chip, a USB virtual COM port, to talk to a I2C TPM, a physical dedicated TPM that we can reach over USB. Then the other interesting example here is the TCTI-SPI-LTT2Go, which is again a TPM on a USB stick using a different type of USB chip solution that establishes the virtual COM port for our system. So let's look closer at our template application that we use throughout this course as a base, as a foundation for performing any of the labs. It's located in our GitLab repo for TC1102, the dedicated repo with the code for this class. There's also a separate repo with all the presentations and slides. So once we take this template, and we'll look at the template in a moment on the next slide, we have to define our own TCTI. And we explain why, because we're going to use a TPM simulator, and by default the TCTI loader will not look for that. So we need to create another pointer variable from this type, TSS2_TCTI_context, and we need to pass that variable to be initialized with a proper configuration string using the TSS2 TCTI loader initialize API. This is a separate API from eSAPI. This API is part of the TPM2 TSS. And here we say that we want to use the MSSIM TCTI library. We want to talk to the localhost, which is this IP address, one of the ways to say it. And then the port is the default one, 2321, and we want to be explicit about which one it is, just to make sure we have it set. Now, once this structure is initialized, we just pass it in the second argument of the ESYS_initialize call. And now that we've done this, we can then go ahead and try to talk to our TPM. In the easiest way, what you find in most situations, even in TC1101, it is, let's try to get some random bytes, some randomness out of the TPM. So we'll use the ESYS get random eSAPI API matching to the TPM get random command. Here we'll see its prototype. We need to pass the context, our eSAPI context, and here the 3 authorization slots that we usually use for MIT, for machine in the middle protection, for password authorization, and so on, or policy authorization, which we'll learn about in this course, we'll leave empty because the purpose now is just to test, hey, can we build the template? Can we use it? Can we use it as a base moving forward? We'll have a dedicated lecture to talk about enabling MITM protection using eSAPI. Then we say how many bytes do we want, and of course we need to provide a place for the bytes to be stored. So let's take a closer look. Here we see the random bytes variable that needs to store all of this data has this interesting TPM2B digest type, and we'll talk about that. Now, the interesting thing is that this variable has to be also a pointer, because the EsysGetRandom function will allocate the memory for this variable. Kali allocated, says here. And this is the template that we have in our GitLab repo for TC1102. As you can see, we have the TCTI variable, pointer variable, which we then initialize using the TSS2 TCTI loader initialize API. Once we have our TCTI set, we pass it to the Esys initialize API using our empty pointer variable Esys context, and the last argument is no, because we just use the latest variant of the ABI for the TPM2 TSS. Upon success, we perform also a startup operation because we're using a TPM simulator. If this was a dedicated TPM, most likely the UEFI or the BIOS would have performed the TPM2 startup command for us. But in this case, we have to do it ourselves. Then we have the pointer variable to TPM2 digest, which will be holding the random bytes we get from the TPM. And as any esapi command, the first argument is we need to provide our esapi context, which is of type Esys context. A bit confusing, but you get used to it. Then we have no authorization sessions. We use none of it using this define, and this is just to test the connection to the TPM. We set our random bytes count, which is a define above main, and you'll find that it's 16 bytes or 32 bytes, up to your choice. And then we just print out the result. Now, let's talk more about the TPM2B structure. The TPM2B structure is interesting in that you come across it often, and the moment you see TPM2B in front of something, is it digest, is it nonce, for example, or data, you can be sure this is a byte-sized array and it stores different types of information. It has always two members, size and buffer. And now what this buffer represents, then we have different union types to match to that on top, so we can use that buffer easier. And as shown here, in most cases, you find that these types are type defs. For example, here the TPM2B nonce is actually a type def to TPM2B digest, and that's okay. It's just the understanding that the TPM2B structures are very useful and very common. You have the size field, you have the buffer field, and the maximum size is defined either by the TPM capability, this one, TPM2 PT input buffer, and we've learned how to query TPM capabilities in TC1101. And also we would be limited by the TPM2B max buffer defined in the TPM2 TSS. The default value that I've seen is 1024 bytes, and this is usually also what we see on dedicated TPM. This is what we usually have as a limit for single writes and reads in the NVRAM even. So it makes sense. To try and use the template, just go build it, try to get randomness, try to get random bytes. Then start to modify the template. Add the Esys create primary call, make sure you define the types required for the output, for the input, populate the needed parameters, ACC, RSA, and of course, don't forget to start your TPM simulator. Please make sure to use the OST2 discussion boards to ask any questions.